Howdy folks, Mr. Reed here, and welcome to One More Question. So what we're going to be taking a look at today are inverses. So I want to say inverse functions, but technically we're going to be looking at the inverse of a relation. So sometimes we might start with something that's not a function, or maybe end with something that's not a function. So we have to be a little bit more careful in when we're allowed to use the word function or not. So that's why I'm going to say inverses of relations. And specifically, we are going to just take a look at exploring a graph of a relation and seeing what the inverse graph would be. So we'll talk a little bit about inverse, we'll do the new graph, and that will be what we cover in today's video. So if that's what you're looking for, let's get to it. All right, so I have a graph of a relation. Now, technically, this is also a function too. So for any particular x value, there is one and only one y value. So if we kind of comb through this thing from the left to the right, some people might do something called a vertical line test. So they take basically an imaginary vertical line and they pass it over that function from one side to the other. And as long as it never cuts through more than once, then it is a function. If it was to cut through at any particular value of x and two or more spots, then it would not be a function anymore, and we'd only be able to refer to it as a relation. So the idea of a relation is it's just for our purposes, we're pairing up quantities. So in this case, an x and a y value are paired up. Functions are special because when you pair things up, there is only one y value for each individual x value. Because of that, they're a special subset or special type of relation. So all that's all well and good, but what is an inverse? So from what you've probably seen so far, inverses are, the idea of inverse is something that undoes. So if somebody was to tell you to add 3 to a number, you probably could get the original number back pretty easily because you could subtract 3 from that. If somebody tells you how to do something where you multiply by 5, well, then you can divide by 5 and get the original value back. Most of those tricks where somebody guesses the original number that was in your head when you tell them the last number all rely on the idea of an inverse. So if they're really basic, they tell you to do this string of things that all together they also are telling you at the same time to undo those things in a slightly different order with some different numbers. So you might be undoing part of it, but eventually you get something that undoes the whole thing, maybe but plus 5 or something like that. So they subtract 5 as their final step in their head, give you the number that you were thinking of, and wow, they amaze the crowd. But the idea of being able to undo an operation or many operations is something that we want to get into and be able to describe. And we're going to say that an inverse to a relation is something that instead of taking your x values and taking them onto the y values, it takes those exact same two sets, but it takes those y values and puts them back onto the x values. Now, most of the time what we'll say is that those old y values are actually the new domain, and so we're going to actually switch the role of the xy. So we're going to have x values that used to be x values, and we're going to turn them into y values. So I'm going to just actually draw really quickly. If I had just a set of the numbers 1, 2, and 3, and I had another set of the numbers 4, 5, and 6, and I said that there was a relation that took the number 2 and turned it into a 4, and took the number 1 and turned it into a 4, the number 2 and turned it into a 5, and the number 3 and turned it into a 6, then the inverse to this relation would be if we could take 4s and turn them into 1s, take 5s and turn them into 2s, and take 6s and turn them into 3s. So if we had something that did that, it would be the inverse of the original relation. Now in this case, both the original and the inverse would be functions because for each input the first time, the 1, the 2, and the 3, there's exactly one output, the 4, the 5, and the 6. When we go backwards, the 4, the 5, and the 6, for each one of those, there's exactly one output, which is going to be the 1, the 2, and the 3. So both the relation, or sorry, the original relation would be a function, and the inverse relation would also be a function. Now, I have a picture, and what we're going to do here is basically say that undoing what's going on here means that each of these points that we could describe nicely, I guess, I'm going to say these 4 points right here, they would have an x and a y value. Think of the x as the input, the y as the output. We want to undo these. So we want to take those outputs that we had and get back the original inputs. That means that our outputs from the first one are going to be our inputs for the second one. Let's write down what we mean by that. So this point right here is originally -2, +1. The input is a -2, the output is a +1. But we want a function that takes an input of a 1, which is our old output, and gives us back the -2. Well, how do we write that down? Well, that would just be if we were to reverse the x and the y values. And that's exactly what we're going to do. So we reverse those x and the y values, we would get 1, -2, which would be right here. I'm going to just go through the other 3 points and do exactly the same thing. So we have a -1, a 0, -1 for our second point. And that's going to become then a -1, 0. I think the yellow's throwing me off. I can't really see very clearly on my thing. Hopefully it's a little better for you. If not, my apologies for my choice in colors on the white background graph. All right, so we would have -1, 0, which would be right here. Okay, so I have to be a little bit careful because I made these open circles to kind of highlight the points I was doing originally. I'm going to do these closed ones to represent the graph that we're currently looking at. All right, next up, I have up here, that's 4, 3. So that's going to become 3, 4. So 3, 4 would be right here. And then we continue to the last point, that is 6, 3. So that's going to turn into 3, 6, because the output, the old one, becomes the new input, and we're trying to get back the original value. So when a 3 gets put in, we want it to kick out a 6. So 3, 6 would be up here. Now, we're going to be able to play kind of this idea of connecting the dots. Now, the first point that I put down here is actually this one. And this one's my second right here, and my third, and my fourth. So I'm going to make sure I play connect the dots all with straight line segments because that's how the original graph is also connected. So I'm going to do this to this, my first to my second to my third, and my third to my fourth. All right, now, one of the kind of neat things that happens here is that we get this really nice symmetry that starts to occur, or is occurring. If you have the option of kind of rotating your screen, if you're holding it in your hand, you have a phone or a tablet, that would be a pretty cool thing to do. So you could line it up so you could see the line of symmetry kind of vertically appear in front of you. A lot of us, that's a little easier to do. If you're sitting on a screen that doesn't rotate very easily, you might be going something like this instead. So tilt your head to the side a little bit and say, oh yeah, okay, I can kind of see that line of symmetry. Now that line of symmetry is actually a fairly important line and an easy line to be able to describe. So if I were to start down here and I were to draw up like this, I could show that there is a line of symmetry that is the equation y is equal to x, and it would split my original relation and my inverse relation right down the middle. And there would be a line of reflection that is the y equals x line. So really what we can do, if we want to graph the inverse relation, we can either just write the points down and switch all of our x and y values, that will do it, or we could draw a line of reflection. I'm not very good at this, to be honest, and you could visualize what the exact reflection would look like across that line. I'm not really good at freehanding that sort of thing. I stay away from it generally, but if you are able to do that, then that would work out every time as well. So that basically is it. This is the inverse relation. In this case, the inverse is actually not a function, even though the original is. So if you pass a vertical line across the original, it will only cut through once at every x value. But if you do the same on this new function, new graph that I have drawn, it is not a function, so it will cut through twice in many places, including, for instance, this one right here. So if I were to draw a nice vertical line there, I'd see it would cut through the yellow twice. And actually, even worse, if I keep going up here, it's going to cut through an infinite amount of times, because all of the real values between 4 and 6 are going to lie along that vertical line for the y values there. So hopefully that was helpful, give you an idea of what inverses are, specifically when I'm talking about a relation. And we can just do the old normal function check of doing vertical line test in order to see whether the function that you're currently, or the graph that you're currently looking at is actually a function. Now, before I go, I should probably tell you that there's a kind of a neat little thing you can do. If you don't need to draw the graph of the inverse, but you'd like to know if the inverse is going to be a function, then really what you need to know is, are there any places where we have two x values for one y value? And the way that we do that is just a horizontal line test instead of a vertical line test. So a horizontal line test would be if you were to cut through the original graph twice or more at any particular y value, then what's going to happen is once everything switched x to y and y to x, then you'll see that it will actually cause the new relation, the inverse, to fail the vertical line test. So we can test the original with the horizontal without having to draw, and that will tell you whether the new one's going to be a function anyway. Hopefully that was helpful for you. If it was, like, subscribe, and as always, take care, folks.